Welcome to Chapter 5, T-Test and Welch two-sample t-test. This video shows how to process the t-test and Welch two-sample t-test. You can watch the entire video or use the time slider to navigate directly to any time point. These tests compare two groups of continuous variables to determine if one group statistically significantly outperformed the other. In this example, the participants are randomly assigned to one of two groups. The participants in Group 1 had pet therapy with a beagle, and the participants in Group 2 had pet therapy with a Labrador Retriever. After 30 minutes, the researcher administered a stress survey to each person in each group, which ranges from 5, low stress, to 25, high stress. Those in the Beagle group had a mean stress level of 11.91, and those in the Labrador Retriever group had a mean of 10.64. The t-test will compare the groups to each other and compute a p-value. If the p-value is less than or equal to 0.05, we would conclude that there is a statistically significant difference between the groups. One group substantially outperformed the other. If the p-value is greater than 0.05, we would conclude that there is no statistically significant difference between the groups. The groups performed about the same. The t-test has two pre-test criteria: normal distribution in both groups and homogeneity of variance. If these criteria are satisfied, then run the t-test. Otherwise, run the Welch two-sample t-test. This example uses the dataset ch05_demo. On the R syntax guide, go to page 5. In Packages, check ggplot2, uncheck HMIS, and check MV-norm-test and psych. To check for normality, copy this line of code to the console window. Change file name to ch05_demo here and here. Then change the continuous variable to stress and change the categorical variable to breed. Copy one of the categories, Beagle, to target category, and press Enter. To run the same test for Labrador Retriever, press the up arrow key and change the target category. Copy Labrador Retriever over Beagle and press Enter. The p-value for both of these groups is greater than 0.05, indicating that these variables are normally distributed. Hence, normality is satisfied. To run the homogeneity of variance test, copy this line of code to the console window. Change the file name to ch05demo here and here. Then change the continuous variable to stress and change the categorical variable to breed and press Enter. Since the p-value is greater than 0.05, this indicates that homogeneity of variance is satisfied. Since both pre-test criteria are satisfied, we'll run the t-test. Copy this line of code to run the t-test. Change file name to ch05 demo here and here. Change continuous variable to stress, and change categorical variable to breed, and press enter. Here we see that those in the Beagle group had a mean stress level of 11.91304, and those in the Labrador Retriever group had a mean stress level of 10.63636. The p-value is 0.02114. Since this is less than or equal to 0.05, this indicates that these means are statistically significantly different from each other. Specifically, those in the Labrador Retriever group had a statistically significantly lower mean stress level than those in the Beagle group. If the pretest criteria weren't both satisfied, then the Welch two-sample t-test would be the appropriate statistic to run. To run the Welch two-sample t-test, copy this line of code to the console window, change the file name to ch05 demo here, and here. Change the continuous variable to stress, and change the categorical variable to breed, and press enter. Notice that the means for the two groups are the same in both sets of test results. However, the p-values are different. Instead of 0.02114, it's 0.02259. This concludes this video.